Hi guys, I had something in the post today that I ordered a couple of weeks ago. That was pretty damn fast, to be quite honest, for delivery to Gran Canaria. I was really quite surprised. So yeah, what arrived was this. I spotted this while I was doing the tutorial on transistors, yeah, and I was using a semiconductor analyzer and a multimeter to take some measurements and testing them, and I happened to comment that my semiconductor analyzer bought about 7 years ago cost me about £60, 50 or £60 UK. And I thought, let's have a look how much they are these days. And there I was on Aliexpress, and I found these, yeah, €4.78 plus 165 postage. So that's like 6.78 less 35p. It's like about £6, €6.30 or so, yeah, 6.33 I think. So I thought, well, got to have one of them, haven't you? I mean, the fact of all, I've already got a semiconductor analyzer, and I've also got a capacitance meter, which this also does. Um, it says it's all sorts of things. This testing MOSFETs, transistors, diodes, thyristors, resistors, capacitors. Automatically test, find out which pin is which, I think. Tells you a bit about more what it can do. So I thought, well, let's order one. I think it said somewhere this is also an ESR meter, yeah. ESR, capacitance of a capacitor above 2 microfarads. Yeah, well, resistance measurements. It's just like it measures everything, yeah. It measures everything for like €6, which is like what? That's like less than $8, I think. It's like about £5.50 or something in English money. So I had to order one, yeah, and it's turned up today, which is pretty damn quick from China to the Canary Islands, to be quite honest. So I thought, yeah, let's do a review of that, yeah. So this is the thing that's turned up today. In a little cardboard box and a bit of bubble wrap, and it's sealed in an anti-static bag. Yes, I haven't even opened this. It doesn't have any instructions with it whatsoever. That's the first thing I noticed. So let's have a quick look online and see if it's got an instruction manual. Otherwise, let's just plug and play. Yes, and see what it actually does. Let's just nip back over to the internet again. So LCR-T4 is its model. LCR-T4. So let's have a look to see if there's actually a user manual. Yeah, user manual. Let's see. Oh, T4 LCR user manual. Oh, somebody's asking if there's a manual. Yeah. It looks the same, just in a little clear plastic box. Is there a manual? Is this what you're looking for? Have we got a manual? Well, we seem to have something. Looks like the Chinese. Oh yeah, look at that. Chinese clones. Okay, it has a user manual. Yeah, it has quite an extensive user manual. But let's not let's not bother with that. I can always read that if I need to. Let's see if we can actually do anything with it. Yeah, circuit diagram, all sorts of useful stuff on this here. Okay, measuring voltage, Zeners, frequency generator, frequency measurements. Yeah. Okay. There's lots and lots of information on it. Let's see. Let's see what we got for €6. Yeah. Okay. Let's go back to the overhead camera. Let's have a play. So here it is. Let's get into the package. Yeah. And there we have it. A bit of tape around here. There we are. There we have it. Well, a battery connect to a button. It's just a button. Yeah, it's just a button. A little zero insertion for socket. Looks like there's a place where you can solder or put a surface mount transistor on it, maybe hold it or you solder it. And that's what we got. Well, I think the first thing we're going to need is a battery. Yeah, let's get a battery. Okay, so I found the battery. I've zoomed in a bit. I did mention, and you've probably seen before, I already have an ESR meter. You saw me using this, I think, a few times now on the channel, but I have an ESR meter. I also have a semiconductor analyzer. I have capacitance meters, multimeters. So really, this claims to basically do what everything else I've got does, but all in one unit for next to nothing. So first thing we'll do, let's connect the battery and see what we've got. So I'm guessing this is on off switch. Testing. No unknown or damaged port. Okay. Let's stick something in it then, shall we? So let's start with the resistors. Let's just start with the resistor. This is 150k resistor, yeah. I'm guessing we stick it between pins 1 and 2 or 1 and 3, does it matter? Obviously we do have a user manual. I press the button by mistake. Okay, we have got a resistor in there. Let's press the button. 147k. Well, it's a 150. What if we put it between these two pins? I'm guessing it'll say 1 to 3. Yeah, that seems okay. So that's a low value is this. Let's try something low. Yeah, this is a 6.8 ohm resistor. So this is a low resistance. Yeah. Stick that on there. What's it do? Oh, it's not very accurate. I mean, 1.18 ohms. I'm sure this is 6.8. I'll check. Maybe it's just in the wrong little drawer. Nothing. Oh, that's it's not clipped in properly. Okay. Put it between pins 1 and 2. We get it in there. It's a bit fiddly. It's a bit fiddly to get the components in. .2 ohms. Let's see what that measures on the fluke. Yeah, I want to see is it actually a 6.8 or no? Maybe it isn't actually. Maybe it is. It was just in the wrong place, wrong component drawer. Okay. Well, let's have a look. I'm on resistance mode. No, in fact, okay. So that resistor was in the wrong place. Yeah. So yeah, it measured it. Let's look at some capacitors. Just choose something at random. These are 18 nanofarads. Yeah. So what it makes of this. Oh, I think I noticed it turns itself off after a while. That's rather handy. Oh, certainly measures that. No problem with that, is there? No problem with that. Let's try something bigger. This is a 820 mics. Now it doesn't say which is plus and minus. These are polarized, yeah. So does it matter? See, switched itself off again. That's good. Saves draining the battery. Oh, look at that. ESR is 0.2. 811 microfarads. What I've noticed, what I would say straight away with this, let's just reverse the polarity, see what it does with that. Yeah. Maybe it tells us in the instruction book. .2, yeah, ESR. Right. One thing I'll say about this, it's obviously measuring ESR. I mean, it's an ESR meter. Can't knock that. But I was using an ESR meter in a couple of recent videos where I was actually using them to find short circuit high side MOSFETs, which is not what an ESR meter is for, but it certainly did it. And I don't think this would, because the ESR meter I use, this one, has like an instant sort of response, yeah, and this one doesn't, basically. So I can use this effectively in circuit to trade. You know, I was looking for shorts with it. I'll link to the video where I did that. There's two videos, one on a motherboard and one on a GPU. Yeah, and you'll see what I was doing with it. Let's see how accurate that is compared to this one, assuming this one is accurate. So this is the 3300, which it correctly identified, and just checking on what did it say the ESR was. .24. Let's have a look what this thinks. I'll put it onto the same range, 0 to 1. I don't know what this goes up to, by the way. Mode range 1 to 10, 10 to 100, 0 to 1. Yeah. This I know which lead is which because they're coloured. Yeah, there's coloured sockets in the thing itself. And we'll short the two together. I'll just put your fingers on these, make a good connection, and we'll zero it. Yeah. That's pretty much zeroed. Now, let's connect this to our capacitor. Let's connect it up to the capacitor and see what we actually get out of this. Yeah. So it was 0.24 according to the other one. Sorry, I hit 0 by mistake. Let me just zero it again. 0. Okay. Now let's measure it. 0.03. There's a big difference. The other one said 0.24. This is saying, well, it's 10 times less. Yeah, 0.029. That's interesting. The thing is, I don't actually know which is right. If you know what I mean, I don't know which of these, because this is not calibrated. Yeah, but I'm certain I use this ESR meter for some things that this won't do. But we'll check the price of this one. Let's have a quick look now. This one here, this MESR 100. How much are those things? Let's have a look. It came from Aliexpress, so that's probably a good place to look for it anywhere. MESR 100. Yeah, 35. So you can see, obviously, it's 7 or 8 times more expensive than the other one. But I'm quite convinced that my ESR meter does things that this one won't do. Yeah. So in that case, yeah, I'll keep that as an ESR meter for sure. Okay, so we've measured some capacitors. Let's have a look at some diodes. Let me get a couple of diodes and see what they do. Okay, let's try some diodes in this. Yeah, so this is a 1N4007. It's a common rectifier diode, 1 amp, 1000 volt. So let's see what it thinks of this. Yeah. Just happy. So you can see the, oh, it's even showing you the capacitance of the diode. That's quite nice. I'm not sure why you need that, but it's quite nice. And the forward voltage drop there, the orientation, that's good. This is a 1M4148 little signal diode. Let's see what he thinks of that one. Okay. Yeah. And capacitance 0. So again, it's picked that one up. It's okay with that. Let's try a diode network. Yeah, well, and a Schottky diode. Let me just get my hands on a couple of those, and we'll see what he thinks of those. Okay, so Schottky diodes. Well, these are Schottky diodes. Let's see what he thinks of one of these. It fits quite nicely in there at least. This should get a low voltage drop, like 0.2 or something like that. Yeah, 0.2 millivolts. That's nice. And again, it shows us which way round it is. So look at diode matrix. So this is basically two diodes in one package. If you see the symbol on it, yeah, you got it there. Yeah, so it's like common cathode. Yeah, two of them. So this should see two diodes. Let's see what he thinks of that. Yeah, looks like the Schottky diodes as well. Very low forward voltage drop across the junction. Okay, it's quite nice there. What else can we try? Yeah, we'll stick with diodes. Let's have a look at some LEDs. Yeah, so this is, I think, is a red LED. We'll pop this in here. So I'm expecting this to have a voltage drop about 1.5 to 1.8, and it might even flash. Let's see what it does. Yeah, it's lit up, it flashed. Yep. Okay, yeah, 1.86. Red LED. Some blue ones. These would have a higher voltage drop, yeah. So stick one of these in. Put it the other way around. Huh? 2.79 as you expect, higher. Let's see what it thinks of a bicoloured LED. So bicoloured LED will have 3 pins on it, yeah? And it'll have 2 colours basically in the same LED. So it's a 3-leg device. This is one salvaged from something, but it'll see if it'll fit in. Yeah, it's in there. See what it thinks of this. It's having a good think about it. Oh yeah, look. 2 diodes, common cathode, and 2 different voltages. I'm not sure what colour that one was. It was flashing, but I didn't really see exactly what it was doing. Let's try another. I've got a few of these. Let's try another one. See what it thinks. Another bicoloured LED. Yeah. What colour is it? Yellow. Just a red and green. Yeah, red green. Yeah. Yeah. I have to say, I'm quite pleased with that. I mean, the Atlas semiconductor analyzer I have would do the same, but for the price, you know. So either that isn't in right or it's no good. This has very short legs on it. It's been salvaged, so maybe it's just not making contact. I think I've got it this time. Yeah, it got it. Okay, so bicoloured LEDs, no problems at all. It doesn't say it's an LED, but by the forward voltage drop, you'll know that's an LED if you know a little bit about diodes. Last thing with diodes then, it's also, I noticed in the manual, it specifically said that this will test Zener diodes. I think it said above 4 volts, so let's try that. So I've got some 3.9 volt Zener, and I've got some 4.7, yeah? Now let's try a high voltage Zener. It's not very high, yet much higher, but let's go up to a 30. So let's see what it makes of these. We'll start with the 4.7 first, because this is within its basically within its range, yeah, I think. Let's see if we figure out what the range is. Obviously there is a manual. So there's a Zener diode. What's he think of that? Well, it just thinks it's a diode. It doesn't say it's a Zener. It's right the way around. I mean, obviously a Zener diode conducts one way. It is just a diode. That's correct. But it didn't see it as a Zener. Okay. Maybe we need to read the instructions. Yeah. So let's just not kind of declare that as failed yet. Let's have a look at that when we've actually read the instructions to see how it's supposed to work. Yeah, that might be a good idea. Okay, let's try and find a few more things to test. Okay, let's go on to a few transistors. So this one is a BC327, I think. One moment. Yeah, BC327. So this is a common type of PNP transistor. Yeah. So let's stick this in here and see what it reckons to this. It's a little bit more fiddly, this. The Atlas, obviously, it has the little leads with the clips on, which makes it easy to attach the device you want to test on this one, yeah. But yeah, I assume you could effectively put 3 short wires off here with little clips on the end if you wanted to, and do the same. Yeah, that's a PNP transistor, yeah. Nice little symbol, tells us the gain. Say UF 630. Is that the base voltage? 631 millivolts. Looks about right. I'm not sure what the UF actually means. So that's a 327. Let's see if we find this one, a 337 in NPN. Let's have a look at this one. Yeah, it's an NPN transistor. I'm thinking this is the base emitter voltage. I'm not sure. I really don't know what it means by that symbol UF. Yeah. Okay, so they worked all right. What would be interesting to try actually is to compare the gain on this compared with the Atlas and see if they're very similar. You'd expect them to both have a similar reading. Yeah. Okay, so which one's this one? Is this the NPN or the PNP? This is the NPN. Okay, so gain HFE is 430. Let's see what the Atlas makes of that. Again, this Atlas is not calibrated, so if they're not the same, I can't tell you which one's actually the accurate one, to be honest. But it'd be interesting to see if they are basically the same, yeah. So that was giving 430. What's this give? Takes a similar length of time. 263. Okay, so they're giving definitely different gain. I mean, gain can depend on a few things like the collector current and such like. Yeah, there are parameters which will change the gain. Base current again will change the gain. So I can't say one is more accurate than the other, just that they read differently. Yeah. Okay. So that's those. Let's have a look at these. These are interesting. I bought 5 of these if you watch the power supply video, and I used 2 of them to repair the ATX 600 watt power supply. So these are a 2SC 3320. Yeah, you see there, 3320. Okay, there you go. Interestingly, the Atlas tester was identifying 3 of these as being germanium transistors, when in fact they're silicon transistors, and the other 2 it identified as silicon. And it seems to be that if it reads a base to emitter voltage less than 0.45, it will think it's germanium. Which sort of makes sense, because a germanium would have a base emitter of about 0.2. So this is saying 0.54, yeah. And this is saying it's a germanium transistor, but they're not, they're silicon. And all 3 of these are doing the same thing. So I'm interested to see what this thinks of them, yeah, because certainly they're not identified. Now the problem here is, can we even fit it in? So here's the first problem we've got. We can't fit the transistor in, yeah, it won't go in the socket. Can can I get across here? Not easily, no. So that's first problem I can see with this, is that in some cases the device will not fit in. I can try and cobble it in just to get you to just push the legs together, yeah. Otherwise you'd have to make up some like extending leads, yeah. It's in. I can't close the clip, I can hold it in place. What's it think of it? NPN. Ah, so this doesn't even say if it's silicon or germanium, it just tells you it's NPN, yeah. The gain's about the same, yeah. Okay, again, I'm not sure what the UF is. I'd have to get the manual. Okay, so that comes to nothing really, because this doesn't actually say if it's silicon or germanium, but it certainly recognises it as a NPN transistor, the same sort of gain that I was getting on the Atlas. So yeah, I'd have to say that's pretty impressive, really. Can we try one or two more unusual semiconductor devices? Okay, yeah. Just get the Atlas again. These are 2SK30A. These are JFETs, junction FETs, yeah. Not a very common device in anything I've come across for repair. So let's have a look to see what the Atlas thinks of it first. And then let's put it into this cheapo component analyzer and see what it says. So this is the Atlas. What's it think of this? Yeah, an N-channel junction FET, but it doesn't know which is the drain and source. But the red's the gate. Oh, that's interesting. Yeah. So it can't determine the drain or source. It just knows which was the gate. Well, let's put that in here and see what this thinks of it. Yeah. There it is. It's in there. So let's see what it says. N-channel junction FET. Oh, and it knows the draining source. That's interesting. That's interesting. So that actually determined that easier than the Atlas did. Let's try another. I've got a few of these. Let's just try another one in the Atlas to see whether the Atlas can actually determine. I want to try it on here first, just to see. Since this one happens to be switched on, it's here. Yeah. Yeah. Drain and source. What's the Atlas think of that? Okay, move on. Yeah. Okay, so that's like 1-0 to the Atlas because what does it do now? No, not the Atlas. 1-0 up to the SR meter because this was definitely far better as an SR meter. But I'll give this one against this one because it actually identified those JFETs and the Atlas couldn't do it, even though despite the fact it's like 8, in fact I'm not sure what the price that one is. We'll look it up at the end. Probably 10 times the price, yeah. Okay, let's see what else we can find to test here. So that was JFETs. These are N-channel MOSFETs, IRF640. Let's stick that in. What do you think of that? N-channel MOSFET. N-E-MOS. Okay. Oh, no symbol. Nice little symbol that. I do like the way this puts the symbols up on there. It's nice. N-E-MOS. Let's see what the Atlas thinks of it. Okay. Enhancement mode, N-channel. Oh, so NE must have been N-channel enhancement. That's what the NE was. Again, this is identified all the pins. So yeah, they both did a good job on that. But without doubt, this presented it nicer. Yeah, it looked nicer on the screen. Let's see what else we got in here. Yeah. these are P channel, yeah. Got some P channel MOSFETs here. I just get them so we can see them. Yeah, these are some P channel MOSFETs. Not sure the exact part number, but I've got them in the little drawer that says P channel MOSFETs, so I'm guessing that's what these are. Yeah. Stick it in the analyzer and see what it's there. See what it thinks of that. No, doesn't seem to think it is what that's. Let's try again. Maybe it's a duff one. No, doesn't know what that is. What's the Atlas think of it? There we are, it's on there, yeah. What's this think of that? Ah, that's interesting. So this identifies this correctly, but this one failed on the P channel MOSFET, yeah. I've got a few more in the bag, so let's just try another one, just see if that was some sort of fluke, yeah. I mean, they're the same type, but I have got a few more, so let's give it another chance. No. Either it doesn't support P channel MOSFETs. Effectively, I'd have to look at the manual. There is a manual, or it doesn't like these. Yeah. So that's interesting. We'd have to look at the manual to see if it actually is supposed to work with P channel MOSFETs. We'll do that in a moment, but let's just grab the last of these things. So these are TRIACs. It said it tested thyristors. Again, TRIACs, you find them in sort of equipment that's like running mains powered, disco lighting and that sort of thing, yeah, where sort of low voltage working like mains powered. Oh, certainly recognise that, that's no problem, Luke. So I haven't got any thyristors here, but I'm sure if we put a thyristor in, well, maybe I do have some. I'm sure if we put a thyristor in, it would happily determine what it was. Let's go for the yeah, sensitive or low power TRIAC. It knows it's a TRIAC, yeah. So that's detected. So okay, let's have a quick look to see over these P channel MOSFETs if it's actually supposed to be able to detect those. Okay, so yeah, I just had a quick look actually, and it does support basically detecting the P channel MOSFETs. So that's a failure, obviously. Yeah, there, measurement of P channel MOSFET. So it should be able to do that, and for some reason that feature wasn't working. Okay, so yeah, P channel MOSFET, that it failed. Yeah, everything else we've thrown at it seems to work fine. Let me see if there's any other components we can test. But I think that's probably that's all. Yeah, let's see if we can test this little pad here. That'd be interesting. So I have, if I look at my little box of bits, these are some IRF R5410. These are MOSFETs of some sort. So let's see if we can just get one of these out and hold it against this pad and see if it actually does work that way. See if we can actually do it that way. So if we can just get into this little thing first. Yeah, here we go. Open up the little bugger. Yeah. Come on. Give me a MOSFET. Out you come. I've got one, yeah. Yeah, so I'm guessing this is meant to go on here, and I'm interested to see if we can just literally hold this in place with the fingers, yeah, and test the components. I'm holding that against there, yeah. Let's just get this so we can see it. Once again, I'll just position this. I'm holding that in there. See what it thinks. Oh no, just saw a diode, so it's all one junction. So let's try again. Yeah, it did. Look at that. P-channel enhancement MOSFET. That's handy. That is handy because that's something. Yeah, I'm sure we could make a little border, some pads, and some terminal where we can clip these onto it. We can make something like that. But that's why reinvent the wheel where somebody's already invented it for you? Yeah, that's handy. I like that. I do like that. Okay, so that's that. Yeah, I have to say overall, I'm quite impressed with this little device. Certainly for what it cost, it was so cheap. I'd be interested just to see if this tests inductors. I didn't notice in the manual, but let's have a quick look see if we can actually test an inductor. So yeah, so here's an inductor coil. None of my multimeters or my capacitance meter can measure inductors. Yeah, I don't actually have a meter that measures inductors. The ESR meter will tell you it has some resistance, which is how I use it for short circuit tracing in VRM circuits, but it won't actually measure it. Yeah, what's this think of it? How about that? Okay, so this also measures inductors as well. I have to say I'm highly impressed with this little bit of kit. For what it cost, which was like almost nothing. Yeah, I can't believe there's any of you guys watching out here who can't afford one of these if you don't already have one. Yeah, I'm highly impressed. It failed on the P-channel MOSFET, and the Atlas found it. But there again, on the N-channel MOSFETs, this could, on the JFET, this could determine which was the gate, the drain and the source end, and the Atlas couldn't. Yeah, so that's 1-1 on that. I've got to give the score to this ESR meter. This is far more capable than the ESR meter that's built into this, and this can do things which hopefully if you watch the video I've shown you how to do with this that you can't do with this. Yeah, so if you get into that short circuit tracing with high side MOSFETs and such like, this is your tool. Even though this is 35 to 40 euros, yeah, that's still the tool for that. And when it comes to ESR, I'll always pick this up. Between the Atlas and this, I have to say this does more. Yeah, this does more. It tests just about everything. I like this little thing here where you can test surface mount components. I love the fact it does inductances. I can't recommend it enough. I cannot recommend it enough. Last thing we'll do, and I did say, let's have a look to see how much the Atlas is, because we know how much this is. Yeah, let's see how much this Atlas DCA55 actually is, if they still make them these days. Let's have a look online. Well, there you go, guys. Farnell, 75 euros. Yeah, I mean maybe we can get these on Ali as well. Let's have a look. No, nothing. So that Atlas is an expensive bit of kit. Yeah, nothing showed up there. Okay. In that case then, I mean that settles it. If you haven't got one of these already, yeah, apart from me, you did find the P-type MOSFET, yeah. Don't get me wrong, I'm happy to own this and I'll still use this, but this little beauty here, yeah, unqualified. Okay guys, see you on the next one.